Today's lesson is 8.5 on finding where f of x equals g of x. Basically, we're just looking to see where two functions equal each other. So we're going to graph this function. This function, f of x equals 3x minus 4, is a linear function because x has an exponent of 1. So any function that has an exponent of 1 as its highest exponent, which is the degree, is a linear function. This one is also a linear function. Okay? So we need to start by graphing our y-intercept, which right here is -4. So we're going to go down to -4, and we're going to put a dot at -4. And then we're going to use our slope, which is 3/1 right here. So we're going to go from our y-intercept, we're going to go up 3, right 1. As many times as you can. Or down 3 and left 1. Okay, and then try to draw your line best you can. All right, then we're going to graph, that's your f of x. If you want to label it f of x out to the side, that would be fine. Then let's graph the other equation. The other function starts at a y-intercept of +11. So you're going to just need to kind of go up there and just put it a little bit above. It doesn't fit on there exactly, but it's not far off. And then count down to right 1 because the slope is a -2/1. As you're going, you'll see where they intersect. Do you guys see that? Okay. Okay, so I need to know what the point of intersection is.
3,
5. +3, +5. Very good. Okay. Any questions there on that one? All right, going to number 2, we are to solve this equation right here. So, in order to solve it, anybody remember what we need to do first here? We're just solving for x. That's all we're doing. Nicholas? Add 2x to both sides because we do not want a variable on both sides, so we need to get rid of one of them. So 3x plus 2x is 5x. Bring down the -4 equals 11. What would we do next?
You add 4 to both sides.
Very good. Add 4 to both sides. So we end up with 5x equal to 15. Last step. Aaliyah?
Divide by 5.
Divide by 5. Good. So x equals 3. Okay. Number 3 says when you found the point of intersection in number 1, the answer was an ordered pair. We got 3, 5. Which coordinate was the solution for number 2? Which coordinate was the solution for number 2?
3, 0.
Which coordinate up here is the solution to number 2? The x coordinate. The x coordinate. Very good. All right. Now, it may not seem quite, you may not be quite sure where we're going with this, but it is all going to come together here in a little bit. I'm trying to connect all of these things, okay? Hopefully you made the connection that this right here, this function, we took this function, 3x minus 4, and we set it equal to this function and solved algebraically. Can you see that?
Yes, ma'am.
Okay, so that's the connection for 1 and 2. All right, now we're going to take each function and we're going to make tables for each of them. Okay, now I've already given you some numbers to plug in. Now these numbers we can do really quickly because they're whole numbers. So we're going to plug each one of these numbers in for x. So starting with -1. 3 times -1 is a -3. Then -4, -7. Good. Plug in 1 next. 3 times 1, 3 minus 4. Okay, then plug in 4. 3 times 4, 12 minus 4.
8.
And 6. 3 times 6,
18.
18 minus 4, 14, right? Okay, let's do the next table. All right, so we're going to plug in for x right here, -1. So -2 times -1,
2.
+2 plus 11,
13.
13. Good. Plug in 1, -2 times 1,
-2.
a -2 plus 11, 9. Very good. Plug in 4. Negative 2 times 4. Negative 8 plus 11. 3. Very good. Plug in 6. Negative 2 times 6. Negative 12 plus 11. Okay. Now, number 5 says the x value where f of x and g of x are equal is what? Go up above to number 1 and 2. The x value where f of x and g of x are equal is 3. They're equal at the x value of 3. You can see that easily here in the graph. When x is 3, that's where they cross, correct? And when you solved here, you got x equal to 3. Okay? How could you use the tables instead of the graph and the algebraic equation solving that we did in 1 and 2? How could you use tables to come up with this value of 3? Nicholas? We could have plugged in some other numbers here. See, we didn't plug in 3. If we plugged in 3 to each of those, we would get 5. You realize that, right? Because that's where they cross at 3, 5. So if we plugged in 3 here, 3 times 3 is 9 minus 4 is 5. Negative 2 times 3 would be negative 6. Plus 11 is 5. Okay? And we didn't plug in 3 here. Well, you might say, well, how would I know? So the goal for today is to be able to use tables to see what the solution would be or where the functions would intersect. And so you're looking to see when is this f of x going to be equal to this g of x. Well, if you look here, if you continue to go more negative with the x's up here, you can see that the answer is going to get more negative, right? Because it went negative 1, negative 7, it's going to keep going more negative. If you continue to go larger on the x value, 4, 6, anything higher, you can see the y value over here, or the f of x, is going to continue to increase as well, right? Well, over here, as this increases, this is going to continue to get negative. So there's no way this f of x is going to match up with this if this continues to get larger and the g of x continues to get smaller. So there's no point in doing any more x values higher than x. Do you see that at least? Okay, so then you say, okay, well, maybe the x values could match up somewhere in here. I didn't try 2 and I didn't try 3, right? There's some more that you could try in there. Okay, and so the point will be today to see where is this value going to be the same as this, or at least as close as possible. Okay, when we plug in 1 here, we get negative 1, and when we plug in 1 here, we get 9. Well, negative 1 and 9 are not anywhere, that's not close to being the same number, is it? 4, right here, when you plug in 4, you get 8. When you plug in 4 here, you get 3. Well, that's a little closer than a negative 1 and a 9, right? Okay, so you're getting closer, but then you start getting further away again, don't you? So it's somewhere between the 1 and the 4, which we know it's 3, but that's kind of what you're going to be looking at. Let's go on. Let's put some more of this into practice here. Okay, so for number 6, this says the graph shows a of x and b of x. Now, a of x is a cubic function. Notice the cube there. That's the degree of the polynomial. That is a cubic function. And b of x is a what? What kind of function is b of x? Linear. Very good. All right. So part A says, how many solutions would a of x equal to b of x have? What do you think? Without doing any work, look at the graph. How many solutions do you think there are here?
3.
You think there's 3? Why would you say 3? Nicholas?
Because each line crosses each other 3 times.
Yes, it crosses in 3 locations. Do you see that? There's 1 there, 1 there, and 1 here. So yes, sure, 3 solutions, okay? Use the graph to estimate the solution. So now we're going to look at the graph and we're going to estimate about what the x value would be at each of those locations. So let's do this first one right here, down in the bottom left corner. About what do you think the x value would be? That would be at about x equal to what? Negative 1? I'd say that's pretty close. It's an estimate, so we're going to put negative 1. At about x equal to negative 1. See, if you're at the origin here, and you go, I don't like where that 0 is. That's kind of confusing. Just be closer here. But if you go to negative 1 and you go down, it looks like they cross somewhere close to right about at negative 1, right? Okay? let's look here at this next one. What x value do you suppose they would be crossing at here? Just take your best guess. X 1.5? Okay, we'll write that one down. And then how about this last one over here? About what x value do you think? 5 point, you think 5.1? 5.2? Who thinks 5.1? Oh, now you're going to change your mind. So we're going with 5.2. Okay, then. I was just going to take a poll. I'm not saying one's right or not. Either way, if it was a guess, both of those are awfully close, and those would both be acceptable guesses. Okay, so let's look at C now. Which solution is the easiest to determine and verify from the graph? Which one of those values is the easiest one to determine? X equal to -1 was probably our easiest one to determine. And it's easy to verify. How can we verify if -1 is indeed the x value where there would be a solution? How can we verify that without using the graph? Because that's how we came up with the -1.
Plugging it in the equation.
Exactly. Plugging it into each of those equations. So that's what we're going to do. We are going to take this a of x function, and we're going to plug in -1. So we're going to write a of -1 equals, and here's where you really need to focus because this tends to throw some people off. We're going to plug in -1 right here for x. So I'm going to write -1 cubed. All right, then I'm going to write -6, and then I've got another x. So in place of x, I'm going to put -1 in parentheses, but it's squared. Put the squared outside. Plus 4, and then in parentheses, I'm going to put -1 again, and then plus 1. Okay, now, the best way, because we're going to have to do a lot of this here in a minute, the best way to calculate this is not to start typing all of that in your calculator at one time. Now, if you had a graphing calculator, that when you typed everything in, it was all nice and neat. You could see everything. You know what I mean? Like when you type all your parentheses, it's really nice, looks like a computer. Then that would be okay as long as you put it in exactly like this. But these are not quite as complicated. Although, I wonder if I know they do parentheses. All of a sudden now I'm starting to second guess myself. Yes, but they do parentheses, but it's not going to keep it all written out, I don't think. When you start hitting add plus something, it's going to try to calculate it right away. Okay, so let's do this. Let's start here. What would -1 cubed be? -1, okay? So we write that down underneath here. What's a oh wait, before we do -6 times this, what's -1 squared? Because the squared is just on the -1. That's going to be +1 times this -6 is going to be what? -6. We're multiplying. And then over here, +4 times a -1, -4, and then we have our +1. Now that would be okay to calculate in your calculator, a -1, -6, -4, +1, or you can do it in your head.
Oh, yeah.
Tell me what you get.
-10.
-10. Okay. So when x is -1, y is -10. Right down there. I was trying to, you can't see that. That's too low. There. I was trying to highlight at -1, -10, right there. That's actually where that big loop crosses. That's right where it hits -1. Is that -1, -10? Right? Okay, so let's go ahead now and try the b of x, which this one's going to be really easy because b of -1, there's not as much to do. So we're going to do 2 times -1 minus 7. 2 times -1 is -2 minus 7 is -9. Okay, so that one, when x is -1, -9 is right there. So that's where the line is crossing at -1, and down here is where the cubic is crossing -1. So it's awfully close there. So you might say, well then, if they don't intersect right there at -1, because it would intersect at -1 if we got the same answer here. We'd have to get the same number here when we plug it in. Okay, but we didn't. But we were close enough, and that's okay. That's close. All right. So now let's go ahead. Now we kind of checked this -1 a little bit. We were close, not quite. Now let's check this x equals to 1.5. We think x is 1.5, okay? So because we don't have a lot of time, let's not fill in this entire table. Let's go ahead and check the points between 1, 3 and 1, 7. We'll do that. So what this means is I'm going to need somebody to plug in 1.3 into my a of x and b of x and get those two numbers. So we can do tables. Let's see. We have 1, 2, 3, 4, 5, 6 tables. 1, 2, 3, 5 numbers. Well, that's okay. So let's see here. We'll let you guys right here go ahead and do 1.3. Plug it into both of those functions. You guys do 1.4. In the back, 1.5 and 1.5. Right here, 1.6 and 1.7. Plug those numbers into the a of x and b of x functions. While you're doing that, I'm going to go ahead and write the answers on the chart. But I just want to make sure you understand how to calculate. Okay? So you work on that, and then we'll fill in the chart here. Or you can copy down what I have in a minute. But right now, you see if you can come up with the correct numbers. And if you're watching this, I would just pause it and try all of those while you're at home, and then you can start it back up and see if you're getting what I'm putting in the computer here. And as my groups here are plugging in numbers, if you want, after you plug it in, you can check to see if you're right. Oops, that's not right. My suggestion while you're plugging the numbers in is that you do like we did up here in part C, where you calculate each piece and then add or subtract. Are you guys coming up with what I have up here? I just went out to like the thousandths place on the a of x and the tenths place on the b of x. There's really nothing that says how far to go out. You just need to be able to go out far enough where we're comparing the a of x and b of x. We're trying to see when these would be the same, because we think that they're going to be the same at 1.5. That's what we think, right? So if you've got them all calculated, you should write down what I have up here on the board. So you can copy these numbers down, and while you're copying them down, because it looks like some of you are, bless you, already copying things down, which is great. I want you to be looking at the a of x and b of x and see at what x value do the a of x and b of x look closest together. You guys see which ones would be closest together? What x value has the results being closest?
1.6.
1.6. So circle this, because you get -3.864 and -3.8. That's awfully close, right? Okay. So we guessed 1.5. A little bit closer would have been 1.6, right? Okay, then when you go down to 1.7, you can see they're getting further away from each other. Now, you might say, well, those aren't exactly the same. Well, they're not. What you could do at this point is you could make another table, and you could take your x value and go out to the hundredths place and start. So whereas we tried 1.6 here, and we narrowed it down to, it's going to be 1.6 something, right? So you could then do 1.61, 1.62, 1.6. to see if these get even closer together to get a more accurate x value. But negative 1 point or positive 1.6 is very close, very close. Okay, so that's what I would go with. And by the way, as you're working these tables, if you find where your functions are close together, you don't need to continue filling in the table just to fill in the table. The purpose of the table is to see where they're close. If you find a close and it's the closest and you can tell that above and below it, these are getting further apart on both ends, then stop. You've already found what you're looking for. Okay, so the solution would be they'd be crossing close to 1.6 on the x-axis. Oh, over here. This is the one we were looking at. Okay, let's look now at E. Now, E is the third one that we're going to check because we thought it was going at 5.2, although some people thought 5.1, right? So we'll see here in a minute, right? Okay, so let's go down. So we know it's between 5 and 6 for sure. Okay, as a matter of fact, because we thought it was 5.1 or 5.2, let's just start calculating values that go from 5.1 to 5.4. Okay, so you guys take 5.1 right here, you plug that in. Lindy's table 5.2, you guys 5.3, and you guys 5.4. Go ahead and plug those in. A little extra practice, and as soon as you get those two plugged in and they look like what I have on the board, then start copying the rest of these numbers into your table. It's a lot of calculating. Thank goodness for calculators. And then we're going to do the same thing here after you guys get this figured out. We're going to see where the values are closest together. You okay in the back?
I got it.
Are you guys making sure you take it one step at a time? You take the, I don't know, what are y'all plugging in? 5.3? So you got to do the 5.3 cubed, then write that number down, and then negative 6 times 5.3 squared, and write that number down. Are you guys doing that one little number at a time like we did? Okay, as soon as you get those and you feel comfortable with what you came up with, and hopefully you came up with what I have up here. If you don't and you need some assistance on how to plug these numbers into the calculator, then you need to see me before you leave class, or if you're watching this video, you need to email me because I can send you something to help you, okay, because it's very important that you can calculate these values. So while we're looking, I'm going to have to kind of go ahead and I'll try to talk slow because I know some of you are still writing. But while you look here, what x value would you guys say gives you the closest values, where these are the closest, like 5.3? Because if you look at 5.2, you're going from 0.1 something to 3.4. That's like a difference of over 3, right? Okay, then you come here. These are only about 1.1 apart, right? And then these end up being 1.3 apart or something. So you're right. It's going to be around the 5.3 x value. Now, let me just reiterate that if you wanted to get even closer value, because these are not the same number, right? You could take the 5.3 and you could make another table and do 5.31, 5.32, 5.33. You could take it out, then take the x value out to the hundredths place and start plugging those numbers in and see. Okay, we're just trying to see how close we can get this, where these would equal. All right, great. So let's go to the next page. Oh, in case you're curious, the actual answer here is 5.346. Okay, so if you did take the 5.3 and did 5.31, 32, 33, 34, you would have seen that they got closer at 5.34. And then maybe you choose to make another table and go 5.341, 5.342, 5. You know what I mean? You just keep going out further until you narrow it down. It's kind of like a little game. Just how close can you get? Okay. Okay. I don't know that that's a fun game for some of you, but it could be considered a game. All right, so let's look at number 7. Number 7, we're going to do some algebra. So a little break from the tables, which is nice. We are going to solve this algebraically. So if we're going to solve this algebraically, we're going to set these equal to each other. So we're going to have 2x squared plus 10 equal to 4x plus 16. Now, because this has a square in it, we've got a exponent of 2. This is going to be a quadratic, okay? And there's 3 ways you can solve quadratics. These don't get solved the way we solve linear functions, where you can just add, subtract, multiply, and divide. Not quite as easy as that, because we have the x squared and we have the x here. There's 3 ways. Who remembers one of the 3 ways we solve a quadratic? One of the 3 ways that we find the zeros or the roots. That's solving. Kiana? The quadratic equation is one way. Who can tell me another way we can solve for the roots or the zeros, which is what we're doing? Kiana? Completing the square. There's a third one, and it's the first one we did in the last unit. Factoring, yes, which I would always try factoring first because it's faster than completing the square in the quadratic formula. But for any of those, who remembers what the equation had to look like in order to start any of those methods? Kennedy, I think you said it.
Me?
What did you say a minute ago?
I don't know.
Oh. Nicholas?
A squared plus B x.
Yes. It does need to be in that form.
And then plus C.
Kennedy?
Needs to be all equal to 0.
Yes. But you're right, Nicholas. It's going to be ax squared plus bx plus c, but then it also has to be equal to 0. It has to have both of those. You guys are right. So we need to subtract the 4x. So that's going to move over, and subtract the 16 over. So when we do, we get 2x squared. Then we have to put the minus 4x next. And then we have a positive 10 and a negative 16. So that's going to give us a negative 6 equal to 0. Okay, then if we want to try factoring, let's factor out the 2. So we have x squared minus 2x minus 3 equals 0. All right, and then we try to factor what's in parentheses if possible. Now I'm going to set it up, but it may not work. We may not be able to do that. Remember, we take the negative 3 here, and we say factors of negative 3 that would add up to negative 2. Can you think of any? Aaliyah? Negative 3 times positive 1 is a negative 3, and it adds up to negative 2. Very good. Put your x in here. All right, now to solve, we simply take each parenthesis and we set them equal to 0, don't we? X minus 3 equal to 0 and x plus 1 equal to 0. We don't do anything with that 2 out front when we're solving. So we get x equals 3 as a solution and x equals negative 1 as a solution. So it's possible that in a table you might have 2 areas where the numbers end up having the same y value. So you just want to check. You want to check and see. Okay. So let's look at number 8. Number 8 says if h of x equals this and d of x equals this, find the solution to the nearest tenth for h of x equal to d of x that's on the interval negative 5, between negative 5 and negative 1. Okay. So, I don't guess we have, did I not put enough room in here? Is there room over on the side of your paper here? Can we do it here? Okay. So what we're doing is we're going to do x values where we have between -5 and -1. So -5, -4, -3, -2, -1, like this. For h of x and d of x.
It's not on the screen.
What?
It's not on the screen.
Oh, thank you. Okay, so I'm trying to cut some time here. If we do this, and I give you some answers here. -3, if we plug in -3 to h of x, somebody calculate this for me. Take a -27, add 18, no, add 19. -27 plus 19. What is it?
-8.
Okay, so basically we took the interval that was given to us, -5 to -1, and we want to see where the values come closest together. And let's, you know, I probably should have done -4 also. That would be -6 over here. Somebody calculate 4 times 4 times 4.
64.
So do a -64, a -64 plus 25. Okay, so you can see right here, these are far apart, aren't they? Okay, and you can see here, these are 4 apart. And then what happens here? No, because one's a 5 and one's a -2. That's 7 apart. So it's somewhere in between here, right? In between the -2 and the -3, right? Which is why now I have this table set up for you right here. Okay, so we started with this interval. We found out where they were closest together. Then we started going to the tenths place. Okay, now because we are just running short on time, I'm going to start giving you numbers to write in here. I wish I could give you the whole table, but we just don't have that much time. I'm going to start up here at the -2.6, and I'm going to tell you what those values would be. Now, you guys are capable of actually calculating these. You know, you were just doing it, right? Okay, I'm just going to go ahead and give you these values. So, copy these down. Okay, so since we knew it was between -2 and -3 based on this chart over here, correct? Then we brought it down to the tenths. So if we look over here, and I picked over here because I knew that over here is where they get closest together. I was trying to save us some time. Can you see at what tenths place these would be closest together?
3.7.
That's a whole. That's one whole apart. This right here is closer. You see that? So 2.8 is going to be the closest. So I would circle that. But I guess I want to make sure you guys are clear on how to take an interval that's given to you with whole numbers, find out the 2 whole numbers it comes between, then create another table where you go by tenths between those 2 numbers from -2 to -3. You guys do see that?
Yes.
Okay, and then you see where these come together. And you see these 2 values are coming from the 2 functions given to you in the problem. Honest? You're not just saying yes because I'm videoing? We're good? Okay. Okay. All right. Because this can be complicated. Okay. And then part B has us doing the same thing, taking the interval between +1 and +5, and you would be doing the same thing with +1 through 5, and then you would, obviously based on my chart, obviously it was discovered that they come closest between 2 and 3, so then that's why this is set up. And I'm just going to go ahead and tell you that they come closest together at 2.9 when these are all calculated. We just don't have time to do all of those, but you would do exactly like we did in part A. So for those two functions, they actually come close and cross in 2 different locations. Okay, let's see if we can go to number 9 real quick. See if we can. If the bell rings, I would really like to finish this, so just sit tight for me, okay? Look here. It says if f of x equals 3x minus 2 and g of x equals x plus 3, the quantity squared minus 1. Use the graph below to explain why there is no real solution, and then solve algebraically to prove that there is no real solution. So looking at the graph, how can you tell that there's not going to be a real solution? Paola? They're not going to intersect. So I would just write no intersection. Oh, goodness. Thank you so much. Glad y'all told me that. Sorry, video watchers. So there's no intersection here because you can see that this parabola is here and the line's going to keep going down. They're never going to intersect. So that's great that you can see it with the graph. Let's see how we would know that if we were solving this algebraically. Because if we were solving algebraically, we would write 3x minus 2 equals x plus 3, the quantity squared, minus 1, right? Okay, this is going to take quite a bit of work. The bell's going to ring, so I need you guys to stay focused so we can get through this one. Video listeners, ignore the bell. All right, so here we go. 3x minus 2 equals, you would have to actually multiply x plus 3 times x plus 3 out, okay, where you do this, remember? All right, so I'm going to tell you, it comes out to x squared plus 6x plus 9, but then you have the minus 1. Okay, you can combine those, so I'm going to rewrite 3x minus 2 equals x squared plus 6x plus 8. Okay, then I want to get everything on the same side. So I need to add 2 over to this side, and I need to subtract 3x over to that side so that I have 0 on one side, and I have x squared. Then we add a 6x, but we're subtracting 3x over there, so plus 3x. We have a positive 8, but we're going to add 2 to that side, so plus 10. Now the first thing I would suggest is that you try to factor, but there are no factors of 10 that add up to 3. So my next suggestion, if you like completing the square, more power to you, but I prefer to do the quadratic formula. So A is 1, B is 3, and C is 10. The quadratic formula says do negative b, so negative 3 plus or minus the square root. B squared, that means 3 squared, which would be 9, minus 4 times A, which is 1, and C, which is 10. This is a formula you have to have memorized, so you need to continue working on that. All divided by 2 times A, which is 1. Okay, keep going here. So we have negative 3 plus or minus the square root of 9 minus 4 times 1 times 10. 40 all over 2. Negative 3 plus or minus the square root of 9 minus 40. Negative 31 over 2. Okay, right here's the alarm. Oh my gosh, that was perfect. Ding, ding, ding. We don't want to have a negative under our radical. Hence the reason there is no real solution. Or because there's no real solution. So you would write no real solution. Perfect timing. Okay, that's the end of the video. The rest of you have work on your assignment over the weekend. Have a wonderful weekend. Thank you. What lesson is that? I never can remember. 8-A5.